Now let us come to the see while and do while loops. Okay, so what is the while loop? Syntax of the while loop is while some statement, that is statement 1 we are calling it, and statement set 2 or statement 2, whatever, okay, within the body of the loop. So this is the body of the loop. So okay, so the same task of printing Shatadru 20 times is like this: int I equals to 1. So initialize or assign, okay, as the case may be, the integer to 1. If it has not been declared before, you declare it here. Otherwise, okay, if you have declared it before, you initialize it to 1. By the way, from what we have learned about the preliminaries of C, if you have not declared it before and you've had some executable statements, then you cannot declare anything here. So you have to put it within the scopes, within braces. But anyways, so int I equals to 1. So while I less than equal to 20, this is the condition checking. So repeat it until it is I is less than or equal to 20. So repeat whatever you have to do here until I is less than equal to 20. This is the loop body. So it goes printf my name is Shatadru and then I++. So this is the adjustment with the increment by 1. Okay, so this will check whether I is less than equal to 20 or not, which is the true because it's 1, so which is true. So it will come to the body of the loop and then it will go printf my name is Shatadru. So it will print my name is Shatadru and then make I to 2 because it was 1, so it would become 2, and this is still true, so it will do it again. Okay, then it will come back and make it 3, then 4, then 5, then 6, like this will go on until 20, and that's the last time my name is Shatadru will be written on the screen. Here you can see there is a gap, there is no new line, so it will be printing side by side my name is Shatadru, like this. So basically, so I less than equal to 20. Now when I becomes 20, the last time the printf statement will be executed, as well as the I++ statement. When the I++ statement is executed and I is already 20, then it becomes 21. When it will check this, it will become false, it will come out. Now since this loop condition is actually checked before the body of the loop is entered, that's why it's called an entry controlled loop. It's sometimes colloquially termed as an entry controlled loop. Okay, you must remember something. As opposed to the for loop, expression 1 is executed as long as the loop is active. So as long as the loop is active, this will be executed. This will go on being executed. For example, this will be executed, then this will come back here, then this will be executed, then this will come back here, then this will be executed, and this will come back there. So because it is statement 1, do not think it will be executed only once, as in the case of for loop, which is not the case here. So that means that if you make while int I equals to 1, then you do as usual printf my name is Shatadru, then I++. This will go on forever. Why? Because each time it comes back to statement 1, it makes I as 1. It makes I 1. It assigns the value of 1 to I. It declares a variable I and assigns 1 to it each time it is executed. Even if you omitted int like this, for example, I equals to 1, it will keep on assigning 1 to I, and so there is no condition checking here. There's no condition checking. Alright, so it will go on forever. So that's basically an infinite loop. Not only that, it is possibly processor heavy, because each time what is happening is you are actually allocating a new variable I and assigning it to 1. So each time you're doing this, there is it has to take the extra, you have to undertake the extra work of declaring an integer I and assigning it to 1. So it is basically quite possibly processor heavy. And so the next one is the do while loop. Okay, it's an exit controlled loop. Okay, as it is clear by the form. So you see, first you do this expression, then you check while this expression is true. You do this. So basically it means do this while this is true. Alright. So notice the semicolon here. It is only found in the do while loop. Do not put a semicolon after the while or the for loops. When you are condition checking, do not put a semicolon there. It will end the loop at that point. We're coming to this point in a minute. So it's only the do while loop where it ends with a semicolon. Only the do while loop where it ends with a semicolon. And that is a syntactic necessity to distinguish the do while loop from the rest of the statements. This semicolon is provided. This is not necessary in case of for loop or while loop, so there is no syntax of putting a semicolon after the for loop or the while loop, right? So you see expression set 2, this is this. It is utilized after the loop body is executed in order to indicate whether or not the loop should exit. So int I equals to 1. So we initialized I to 1. Then do this part. So my name is Shatadru. Then put a new line and then increment I and then check whether I is actually lesser than or equal to 20 or not. Now the integer I being within the same scope as the do while loop, this integer I is visible inside the do while loop and so it will be used here. Okay, and it can be used as a loop counter inside it. It's the same thing with the while loop as well. The same thing happens in the case of a while loop as we have seen. So you see, does a loop like this seem strange to you? If it does, then look at this. So I've got a small algorithm here. Do read the temperature of a chemical plant. Let us say that we are operating a chemical plant. Read temperature of the chemical plant. If temperature is high, shut down the chemical plant and do this until the chemical plant is not switched off. So it makes sense, right? So you first read the temperature and check if the temperature is high or not. If it is high, then you shut down the chemical plant and you keep on reading the temperature until the plant is switched off. It makes sense. As I said, this enables us to keep on taking the chemical plant's temperature and necessary action until the plant is switched off. Right? Now, as I was saying, so remember something. You should never put a semicolon after the parenthesis, that is brackets, in the for or while loop. Otherwise, you will end the body of the loop by the semicolon itself. So if you put while int I equals to 10 semicolon printf %di, in this case, we would normally expect it to print 10 because int I equals to 10 is there, right? And this should go on forever. However, it does not, because of this loop here, semicolon, I becomes 10 and then I becomes 10 and then it declares another int I and then makes it 10 and like this, and it goes on like this and this is never reached. The two mistakes here, one is it ends the loop at the semicolon because then the body is never reached. Another one is that I is always 10, which is a true value, so that the loop never stops. Look at the other two loops, for example. So int I equals to 5, while int I equals to 0, printf %di I++. Okay. But here we have added a semicolon. So what do you think will happen to this I? The answer is here I equals to 0. Right? So I value is to false. So this loop ends there. And this body is now not a loop body, it is just a block of code enclosed within braces, which is completely allowable in C. So if int I equals to 5, this one does not exist anymore outside the while loop, and the while loop ends here. So this I equals to 5 will appear here. So it prints 5. So the I equal to 0 inside the brackets go out of scope at the semicolon after the pair of parentheses. So it prints 5 and then stops. Now similarly, if you have int I equals to 0, I less than 20, I++ in case of for loop, and then you do printf %di, and you make a semicolon there, what happens? Basically this prints 20. Why? Because 0, then there is no body here, because you have ended it with a semicolon. There is no loop body here, it's an empty body. So 0, I less than 20, yes, do nothing, come back, I equals to 1, less than 20, yes, do nothing, come back, I equals to 2. Like this it goes on and on and on and on until I is 20. When I is 20, then this one fails and it comes out. Now where does it come out? It comes out to the block here. And this now is not a loop body, it is just a statement enclosed within a braces, a pair of braces, that means within a block. And here, if this I would have been declared before, this would have printed 20. Okay. However, because this I does not exist, because this is int I equal to 0, this has actually ended here, the scope of this I. So when this happens, okay, it does not print a 20. If there is an I before, that appears here. See, if there was another I here which is 15, then it appears here, but the 20 here is lost. Okay, so sorry, there's a misprint here. So when the loop ends here, okay, and at the end, okay, nothing is basically nothing is printed. Okay, so printed basically the I that appears before, right? So basically, if there is an I that appears before, that is printed there. If there is actually an I that appears before, that is printed there. If there is an I that appears before the for loop, that is printed there. Nothing is printed from the for loop. Now come to the other side. So while I equals to 1, I equals to 1 is always true. Okay. So this is an assignment statement. I will always become 1. This is an infinite loop. So there is no condition checking that makes I to be false. Because there is no condition checking. Basically, it's an assignment statement, not a condition checking. There's no condition checking that makes it false. It basically is always 1. Whether I say it becomes 2 here, then it again becomes 1. Then it's 2 here, again becomes 1. Even if it became 2, even if it did become 2, okay, or 3 or 4 or 5 or whatever, if there is no condition to stop the loop, it will not stop. Even if it was not 1, it was something else, but it was non-zero, this would always be true. Even if it's a minus something, say if it's 1 or minus 1, 2 or minus 2, whatever, it's a non-zero number, then I will always be true. This condition this statement will always evaluate to true, and hence what will happen? This will go on forever, and this also goes on forever. In any case, this is an assignment statement, so I always becomes 1. Otherwise also, even if this increment would have worked here, if this was, for example, not, okay, I equal to 1, but say just while 1 or something like this would still go on. It's an infinite loop. So if you have while I equal to 1 semicolon, I is always 1. This is an infinite loop. This is never reached because it never goes out, it hangs out there, because you see, you put a semicolon there, you've ended the loop there, but while I equals to 1, I will always become 1. So basically this is always a true condition, and I mean, if you ever wanted to check the condition, this is always true. And so it is very similar to while true or while 1 do something, and the do something is there is nothing here to do, so basically it will not do anything, it will not come out of the loop. It's an infinite loop, it stays on. Let us now look at the control flow chart for the two loops. The while loop, as you can see, so you have to notice the difference with the relative position of the decision boxes, relative position between these two diagrams. You set you set I to 1, check whether it's less than or equal to 20. If it is so, then you write the name, whatever you have to write. That write is print basically. Then again you set I to I plus 1, that is increment I by 1, and you check whether it is less than or equal to 20. If yes, then you continue this cycle, and if not, then you come out and stop. Because of do while, you set it to 1 and then you write it first. You do the action first, write my name is so and so, and then you just set it to I plus 1, and then check that after you set it, then you check whether it's less than or equal to 20 or not. If it is less than or equal to 20, then you come back, write my name, and then you again do set I equals to I plus 1, then you check again like this. And if it is not, if it is not less than or equal to 20, then you stop. See the relative position of our decision boxes. In case of the entry control while loop, before this action is taken, it is checked. Because in case of the exit control do while loop, the action is first taken and then it is checked within the condition whether this should continue or not is checked.